Hello everyone. In this session, we will dive into the basics of Arduino programming and focusing on fundamental concepts that will help you get started with the microcontroller projects. So we will be using a simple LED blinking program to explore the data types, functions, loops, and more on the WOP platform. So which is a powerful online simulator that makes it easy to code and test circuits without physical hardware. So let's get started. So as we have discussed earlier, so Arduino C and C++ is one of the programming language. So that is supported by the ESP32. So Arduino is the perfect tool for anyone who wants to start exploring the electronics and programming. So you don't need prior experience to create interactive project. So within just a few lines of code and some basic components, so you can bring your ideas to life. So Arduino programming is a valuable skill that can open up a world of creative possibilities. So this is very simple programming language that anyone can learn easily. Okay. So before going into the world of Arduino programming, so it is essential to understand what Arduino is and why it is so popular. Okay. Arduino is an open source hardware and software platform that simplifies electronic designs and programming. So it was created to make technology accessible to everyone. So regardless of their level of expertise. Okay. And then, so this Arduino C and C++ programming language is simple and it is designed for beginners. So it uses a simplified version of C++. Okay. So it is very much similar to the C and C++. So if you see this, so this is the basic Arduino programming structure. So the structure of an Arduino sketch. So this image here you can observe the basic structure of an Arduino programming. So every Arduino program, so we can also call it as sketch. We can also call it as sketch. So every Arduino program or sketch, so it consisting of two main functions. So the first one is setup and the second one is loop. So setup is nothing but here we will put the content, so which runs once when the program starts. And here we used this setup to initialize variables and pin modes and start using the libraries. Okay. So whatever the commands we put in this setup, so those commands will run once when the program starts. So those commands will execute only once. So here in this setup, so we can define or we can initialize variables and pin modes. I mean, which GPIO pin we are going to use in this code. So all those initialization we can put in this setup function. So after that we are having the loop. So loop is nothing but, so here we put the commands which are repeatedly runs. So infinity times. Okay. So if we write any command in this loop, so that command will execute n number of times repeatedly. Okay. And it will also contains the main logic of the program. Okay. So in the loop function, so whatever the commands we place, those commands will runs repeatedly, and the main logic of the code we put it in this loop function only. Okay. So these are the two main functions which are present in the Arduino programming. So first one is setup and the second one is loop. So in setup, we will initialize the variables and pin configurations, and in loop we put the main logic of the function. Okay. So next, so we can use the pin mode declarations in the setup function, and we will write the main function like digital write or digital read operations in the loop functions. Yes, very good. So next, if we coming to Arduino programming components, so Arduino programs can be divided in three main parts. So the first one is structures and the second one is values. So these values includes both variables and constant, and the last one is function. So these are the main three parts of the Arduino programming. So in structures, we have like basic syntax, operators, control statements, and loop functions. So all these concepts so comes under the structures. So after that, we are having the variables. So in variables and constants, so these variables and constants comes under the values of the Arduino programming. Okay. So first, if we see about the structures, so structures in Arduino allows you to group related variables together. So they are especially useful for organizing the data. So these structures are used to organizing the data. So when coming to variables, so these variables are used to store the data that can changes during the program execution, as the name suggests that. So these variables used to store data so that can change during the program execution. So each variable has a type that determines what kind of data it can hold. So we know that we have different types of variables like integer. So we use int for integers and float for decimal numbers, and we use char for the single characters, and we use boolean for true or false values. So all are the different types of variables. After that, we are having the constants. So constants are similar to the variables, but as the name suggests, so their values can't be changed during the program execution. So when coming to variables, so we can change the data which is present in the variables during the program execution. But in constant, as the name suggests, the values can't be changed during the program execution. So these are useful for defining values that remains the same. Okay. So after that, we are having the functions. So these functions are the blocks of code that performs a specific task. So they help you to organize your code into reusable segments. So making it clearer and easier to understand. Okay. So this is all about structures, variables, and functions. So now we will see each one in detail. So structure. So in structures, the first concept is basic syntax, right? So here in Arduino programming, the semicolon represents so ending of the each statement. So in Arduino programming, so we need to place semicolon at each statement ends. Okay. So for example, if we are defining a variable with a data type int, so int a equals to 13. So after the ending of the statement, so we need to place the semicolon. So after that, we are having some curly braces set. So these curly braces always comes in pair, right? If we opens a curly braces, so we need to close it. Okay. So they are used to define the start and end of the functions. So while writing the functions, so we use the curly braces in loops and in conditional statements. Okay. So for example, if you observe this example, so here we are writing a while statement. So after the Boolean expression, we need to open the curly braces. So after writing the all required statements, so after that, we need to close the curly braces. Okay. And after that, so here we are having the comments. So if we want to comment a single line in the Arduino programming, so we can use double slash. Or if we want to comment a set of commands, a set of instructions, so we can use this type of slash stars at the beginning, and at the end we need to use the star hash. So if we want to comment the multi lines in the Arduino programming, we need to use these symbols. Or if we want to comment a just line, single line, so we can use this double slash. So this is all about the basic syntax in Arduino programming. So after that, we are having the operators like, so like similar to the C language. So Arduino C also supports a rich built-in operator. So those provides the following types of operators. So what are the different types of operators we have in C? Like arithmetic, comparison operators, Boolean operators, bitwise operators, and compound operators. So these are the built-in operators which are present in the C. So if we come to the first arithmetic operators, so in arithmetic operators, so here we are having the different types of arithmetic operators. So the first one is assignment operators, which is denoted by using the equal symbol. So this equal stores the value to the right of the equal sign in the variable to the left of the equal sign. So if we use this equals means the value of this right means the value of the y. So the value which is present in the y, that will be equals to the value in the x. And the next operator is addition, which is denoted by plus symbol. So this plus symbol adds two operands like x and y. Okay, x plus y. So this will result in the addition of these two variables. After that, we are having the subtraction. So subtraction, which is denoted by minus. So this operation will subtract the second operand from the first. So it will subtract y from the x. Okay. So after that, we are having the multiplication. After the multiplication, we are having the division. So this division operation divide the numerator by the denominator. This is the numerator and this is the denominator. And after finally, we are having some modulus. So this modulus operator and the remainder of after an integral division. Okay. So these are the different arithmetical operators we used in our Arduino programming. So after the arithmetic operators, we have some comparison operators. So these comparison operators are used to compare two values. So they return a Boolean result, true or false. So the common comparison operators are like equal to. So this operator will check if the value of two operands is equal or not. If yes, then condition becomes true. So please remember one thing. So these comparison operators are used to compare two values. So they, and finally they return a Boolean result. Boolean result is nothing but in terms of true or false. Okay. Next, we are having some not equals to. So it will check if the value of two operands is equal or not. If the values are not equal, then the condition becomes true. Okay. In the equal to, if the values were equal, then only the condition becomes true. In not equal, if the values are not equal, then only the condition becomes true. After that, we are having the less than. So it will check the value of left operand is less than the value of right operand. So if yes, the condition becomes true. Like we have the greater than, and after that we have the less than or equals to and greater than or equals to. So these operators checks if the value of left operand is less than or equal to the value of right operand. If yes, so then condition becomes true. So this is all about the comparison operators. So after that, we are having some Boolean operators. So just now, so here we are having the different types of Boolean operators. So these Boolean operators are used to perform the logical operations and returns Boolean results. So the common Boolean operators are like AND or NOT. So AND means, so this is we called as a logical AND operator. So if both the operands are non-zero, then only the condition becomes true. So we all know about the AND or NOT gates, right? So in AND gate, at the output side, we get 1 only if both the inputs are high. So when coming to OR operation, so this is called as logical OR. So if any of the operands is non-zero, then the condition becomes true. So OR operation is nothing but the addition operation, right? So if any one of the operand is high, so we will get the condition becomes true. Okay. And finally, we are having the NOT. So this is called as logical NOT operator. So which is used to just reverse the logical state of its operand. So if the input is 1, the output we will get 0. If the input is 0, we will get the 1 at the output. Okay. So next we are having a different types of bitwise operators. So like and or XOR. So in the previous we called it as logical and logical or logical not. In bitwise operators we can call it just like binary and binary or binary XOR binary not. Like this we can call this. So this binary AND operator copies a bit to the result of it exists in both operands. So when coming to OR, so this binary operator copies a bit if it exists in either operands. Likewise, we are having XOR NOT, shift left, shift right. So shift left means binary left shift operator. So this the left operand value is moved left by the number of bits specified by the right operand. So these two are used to shift the operand values for particular bits. Okay. So the compound operators, so which are used to combine an arithmetic operation with an assignment. So they allows you to perform an operation and assign the result in a single step. Okay, so common compound operators are like increment, decrement, compound addition, subtraction, compound multiplication, compound division. So all these are examples for the compound operators. So in compound operators, so this will combine an arithmetic operation with an assignment. Okay, so if we take the example of increment, so this will increment the operator. So increases the integer value by 1. So decrement. So if we use decrement operator means the integer value is decreased by value of 1. So we have some compound addition. Add and assignment operator. So it adds right operand to the left operand and assign the result to the left operand. So here in the compound operator, we have the both arithmetic operation along with the assignment. So here it performs the, so it adds the right operand to the left and the result it will be assigned to the left operand. So let us take suppose two variables like X and Y. So here the left variable is X and the right operand operator or variable is Y. So if we use this compound addition, so this will performs the addition of X and Y and the result will be assigned to the X, that is the left operand, and the result will be stored in this X. Similarly, we have the compound subtraction also. So this subtracts the right operand from the left operand and the assigns the result value to the left operand. Okay, so this is all about the compound operators. So in this, it will combine the both arithmetic and assignment operations. Clear? So next, so we are having control statements. These control statements in Arduino programming are very much essential to construct. So that allows you to dedicate the flow, to dictate the, or we need, by using these control statements, so we can dictate the flow of execution in your programs. So these control statements are helping making decisions and repeating the operations and controlling the execution. So based on certain conditions, right? So here we have an overview of some main types of control statements which are used in C. So the first one is if statement. So we all know about this if statement, right? So first it will takes an expression in the parentheses and a statement or a block of statements. So it will consider an expression. So if that expression is true, then the statements or some block of statements, they will be executed. So otherwise, these statements are skipped. So if the condition or the expression we have written in the parentheses of if statement, so if that expression is true, some set of commands will be executed. So otherwise, those commands or those statements will be skipped. And after that, we have the if else statement. So in if else statement, so if the expression is true, one set of commands will execute. So otherwise, another set of commands will execute. Okay. And we have some nested if. Nested if means we can use, we can check the different types of expressions. So for each condition, we have some set of statements to execute. Okay. So after that, we have some switch case statement. So this switch case is also similar to the if condition, but in switch case controls the flow of programs by allowing the programmers to specify different codes that should be executed in various conditions. And finally, we have some conditional operator. The conditional operator is the only ternary operator in the C. Okay, loops. So these looping statements allows you to repeat a block of code multiple times. So why we need this loop conditions mean or loop statements mean? So these looping statements allows you to repeat a block of code multiple times. So here we are having the different types of looping statements like while loop. So this while loop will loop continuously and infinitely. So until the expression inside the parenthesis becomes false. If the expression is true, then the loop will continuously run infinite times. Okay. So next one is do while loop. So the do while loop is similar to the while loop. In the while loop, the loop continuation condition is tested at the beginning of the loop before perform the body of the loop. Okay. So in this while loop, the loop continuation condition is tested at the beginning of the loop. So before performing the body of the loop, so it will test the loop continuation condition at the starting only. So that is about the do while. So after that, we are having the for loop. So a for loop executes statements as a predetermined number of times. So I think so for a equals to 0, a less than 10, a plus plus. So you all know that expression syntax, right? So this for loop executes statements for a predetermined number of times. Okay. So if we initialize it like I less than 10, means it will execute that loops for 10 times only. Okay. So the control expression for the loop is initialized, tested and manipulated entirely within the for loop parenthesis. Okay. So next we are having the nested loop. So the C language allows you to use one loop inside another loop. Nested loop is nothing but writing the loop inside another loop. Okay. That is we called as nested loop. So after that we are having the infinite loop. So it is the loop having no termination condition. So the loop becomes infinite. So these type of infinite loops doesn't contains any terminating conditions. Okay. So this is all about the loop condition, loop statements which are present in the Arduino programming. So after that we are having a main topic in this Arduino programming structure. So that is time. So in Arduino programming, managing time is essential for controlling the delays, right? So this is useful to control the delays and to scheduling the task. And if we want to creating a time-based applications in embedded system, so this time is very important. So the Arduino environment provides several built-in functions for tracking time. Okay. So among them, so Arduino provides 4 different time manipulation functions. So the first one is delay. So the way the delay function works is very simple. So it accepts a single integer or a number. So this number represents the time. So which is generally measured in milliseconds. So if we represent like delay, so if we represent like delay of 1000. So if we represent delay of in the parenthesis, if we write 1000 means, so this represents the 1000 milliseconds. So that is equals to the 1 second. So if we want to make the function delay for 1 second, then in that case we need to write like delay 1000. Okay. And the second one is delay microsecond function. So this function accepts the number similar to the delay function, but there are 1,000 microsecond in 1 millisecond, right? So if we want to represent the delay in microseconds, means here we need to place to represent 1 second, here we need to place a 6 zeros. Why? So for 1 second we have 1,000 millisecond, and in one millisecond we have 1,000 microseconds. So to represent the delay in microseconds, so if we want to give 1 second delay, means we need to mention like 1 followed by 6 zeros. So this will be equals to the 1 second in the delay microsecond functions. So after that, so we are having the millis function. So this function is used to return the number of milliseconds at the time the Arduino board begins running the current program. Okay. Next, we are having the micros function. So these micro function returns the number of microseconds from the time the Arduino boards begins running the current program. Okay. So this is about the time in Arduino. So, but we mainly use the delay function only in our programming. So we commonly use this delay function, okay, to represent the time functions. Okay. So please don't forget about this delay. So if you want to run or if you want to turn on an LED for a particular time period, so in that case we will use this delay function, okay, to hold the LED on that on state for few seconds by using this delay function. Okay. So next we are having constants. So as the name suggests that the constant in Arduino are defined as the predefined expression. So it makes the code easy to read. Okay. So in this Arduino, we have two different types of constants. So the first one is logic level constant and the second one is pin level constants. So in logic level constants, so the constants are represented in terms of true or false. So, but in pin level constants, the digital pins can take two values, either high or low. So, if we are representing a pin level constants, means we need to use high or low. And in case of logical level constants, we need to use the true or false. So, remember one thing, the Arduino is case sensitive. Okay, so we need to write a pin level constant in uppercase only, and we need to write the logic level constant in lowercase only. Okay. So Arduino is a case sensitive language. Okay. So after that we are having the data types. So these are the different. Okay, I will erase that. Okay. So these data types are used to identify the type of data that is associated functions for the handling the data. Okay, so while defining any variable, so we will define its data type, right? Like int a or float x, like that we will define, right? So these data types are used to identify the type of data, and it used for the declaring the functions and variables, right? So these data types are useful for both declaring the functions and variables, so which determines the bit pattern and how much storage space that variable requires. Okay, so the data types that we'll use in Arduino are listed below. So the first one is void data type. So this void data type represents a function so that does not return any value. So void data type does not return any value. And the next one is int data type. So we all are familiar with int data type, right? So this will represent a 16-bit signed integers, so that can hold a whole number ranging from the negative 32768 to positive 32767. So it will hold or stores the total whole number. Okay. So the next data type is char data type. So this char data type is a single 8-bit character data type. So it used to store a single character only. So if we define a variable with a char data type means, so that variable holds 8-bit character data. Okay. Next, we are having the float data type. So this float data type is a 32-bit floating point number. So which is used for storing the decimal values with a precision of approximately from ranging 6 to 7 decimal places like 0.00001. So after 6 to 7 decimal places, so it will gives us the precision of decimal values. Okay. So after that we are having the double data type. So this double will store a 64-bit floating point number. So which is used for the storing decimal values with a precision which is double to the float data type. So in float data type we have the ranging from 6 to 7 decimal places, right? But in double data type the range is from 15 to 16 decimal places. So it may behave like float on some Arduino boards. Okay. So after that we are having an unsigned int data type. So this is also a 16-bit integer. So that can hold a whole number ranging from 0 to 65535. So we know that int data type can hold the whole number ranging from minus 32,000 to plus 32,000. When coming to the unsigned int, so unsigned means so it will holds only positive values only. So this can hold a whole number ranging from 0 to 65,000. So here it doesn't hold any negative numbers. Okay. Whereas int can hold negative and positive numbers, but the unsigned int only holds the positive numbers 0 to 65,000. So after that we are having the short data type. So this one holds a 32-bit signed integer and it is also capable of holding larger whole numbers. Okay. After that unsigned long data type. So this is a 32-bit integer that holds whole numbers. So these unsigned long data type also like the unsigned int. So it doesn't holds any negative values. Okay. So after that we are having the byte. So this is an 8-bit unsigned integer so that can store values ranging from 0 to 255. So this is commonly used for the small data storage. Okay. So it can store values ranging from 0 to 255. And finally we are having the word. So word means, so it is 2 bytes of data. So it holds the 16-bit unsigned integer. So that can hold whole number from 0 to 65,535. Okay. So it is used for efficiency in memory usage. So these are all the different types of data types which are present in the Arduino C programming. Okay. So this is all about the Arduino programming and we have covered the all basic operators, functions, loop, everything. So next, today we will go to the how to simulate the Arduino programming. So because we don't have any hardware boards with us, right? We don't have any hardware or controller boards with us. So now how we will test our codes or how we will see the outputs of each program. So in these codes, we are going to use one online simulating platform for our Arduino programmings. So that is, okay. So these functions we explained in the yesterday session. Okay. Okay, here we are having one more concept. So that is digital IO and analog IO. So we know that in the setup, we will initialize the pin modes of the GPIO pins, right? So how we will define means, so by using a keyword. So the function, okay. So here by using the pin mode function, so which is used to configure a specific pin to behave either as input or output. So in every controller, we are having some GPIO pins means. So GPIO means general purpose input output. So those pins are used as inputs and as well as the output. Okay, we can access the same pin for input as well as for output also. So if we are using one GPIO pin means, so first we need to specify its behavior. That means that pin we are going to define it as input or output. So first we need to define that. So it is possible to enable the internal pull-up resistors with the mode input pull-up. Additionally, the input mode explicitly disables the internal pull-ups. So if we define that pin as an input means, so that will changes the internal resistors to give the access to that pin as an input. Okay. So the general syntax of this pin mode function is like, so in void setup, we will use this function. So like pin mode, in the parenthesis, first we need to give the GPIO pin number. So after that mode, so here the mode represents, so input or output. In which mode we want that pin is to act. Okay. So if you observe this here, the pin is in lower case, but here the only letter M is in uppercase. So in this manner only we need to define the keyword because Arduino is case sensitive. Okay. So the syntax is like pin mode, in the parenthesis first we need to define the pin. So let's say I am going to use pin number 2 as an output. So in that case I need to define, so here 2, so 2 comma, here I need to write the output. So here we need to define the mode in uppercase letters. So we need to write the output in the uppercase only. So we need to like this as output. Okay. So this is the basic syntax for this pin mode function. Okay, next. So digital IO. So once we define the GPIO pin in the setup, so here if you observe, so here we defined a pin with number 2 and we given the mode like output, right? So now in the loop we need to tell how we need to control that pin number 2. Why I am saying controlling means, so it is we declared as output, right? So we can read the data from the input and we can control the data to the outputs, right? So in that manner, so here I mentioned the 2 comma output. Output means, so we are going to control that pin from the controller. Okay. So for that, so we need to use some functions to assign or to control the values to go for that GPIO pin. Okay. So this digital write function is used to write a high or low. So earlier we discussed about some constant, right? Constants like logic level constant, bit level constants. So in bit level constant, so we need to define like high or low, right? So by using this digital write function, we use it to write a high or low value to a digital pin. Okay. So if we write like digital read means, so we used this function to read any values from the input devices. So if we connected any sensor means, so first we need to read the data from the sensors, right? So in that purpose, so we will write the digital read function. So this will reach the value from a specific digital pins. Okay, in general, we write the digital read function for the sensors, and in general, we will write the digital write function for the outputs like LEDs, motors. So for that, we will use the digital write, and for the input like sensors, we will write the digital read. So digital read and write means these two functions will hold the only two values, either high or low, either high or low. Or we can also represent like 1 or 0 or 5 volts or 0 volts. Okay. So these digital IO functions will hold only two values, either high or low. Okay. So if you observe the syntax, So digital write we use for the outputs, right? So digital write, let's say 2 comma high. So that command will turns up the, and that command will sends the high voltage to the particular pin. So if we write digital read means, so from the particular pin, so the controller will reads the data. Okay. So next, analog IO. Like in digital IO, we have only two values, right? Either high or low. So, but in analog read, we have the values ranging from 0 to 1023. Okay. So, we can define any number. So, like in digital IO, here also we are having the two different functions for two different operations. So, here the analog read function, which is used to read the voltage applied to a one of the pins, and the analog read function writes an analog value to a pin. Okay. So, and this is the syntax for this analog IO, which is similar to the digital IO, but the difference is in digital IO we have only two values, either high or low. So, but in analog IO we have the different values ranging from 0 to 1023. Okay. So this is our online simulating platform. So we are going to use in this value added course. So to simulate our embedded system circuits. Okay. So which controller we are going to use in this course? ESP32. Okay. So just to open a browser. Yes. Okay. So just open your browsers and just search for the Oakvy.com. So you can just go to your browsers and just search for the Oakvy.com. So all of you got this website, right? So today we are going to explore the Oakvy online simulator. So this is an excellent platform for simulating the microcontroller projects. So especially focusing on the ESP32 with Arduino programming. So whether you are just starting out or already experienced, so this Oakvy is a fantastic tool. So that makes prototyping and testing easy. So without needing any physical hardware. Okay. So without any physical hardware, so here we are going to simulate our embedded system programs. Okay. So this is a powerful browser-based simulation platform for microcontroller projects. So it supports various platforms like Arduino, ESP32, Raspberry Pi Pico, and some other boards. So it will allows you to create, test, and debug code for the embedded systems without any hardware. So it is very user friendly and it will like drag and drop interface. So you can connect components and you can write code and you can visualize how your code interacts with the hardware. So all in one place. Okay. So here, if you observe here, we are having some points like why Oakvy. So why? Because it is very cost effective. Means we don't need to purchase any physical components. So everything is simulated with free of cost. Okay. And one more point is time saving. So it is very quickly test. So here we can test different designs and we can also fix bugs without assembling the hardware. And because of its flexibility. So, and it supports a wide range of components and microcontrollers. So, including the ESP32, Raspberry Pi, Arduino boards, etc. Okay. So here we can easily share our projects with the team members also. So by using the links. Okay. So now let's go to the process of signing up and how to setting up your first ESP32 project. So just search for the Oakvy.com. So this type of interface you will get, right? So here we need to sign up. So if you have already an account in this Workbee platform, so you can directly sign in. So otherwise we need to sign up. Okay. So all of you got the sign up option right here. So at the right top, so here you will find the sign in or sign up option. So if you are a new user means, okay, so we are all new users, right? So that's why we need to click on this sign up. So here I'm going to click on this continue with Google. So you can sign up using your Google account, or you can create a new account by entering your email and password. Okay. So I'm here just continuing with my Google account. So just give continue. So after completing the sign up process, so you will be redirected to the Mokpay dashboard, right? So where you can create and manage your project. Okay. So signing up is, so here the signing up is optional. So, but having an account allows you to save your projects and share them with others. Okay. So you can access your work from anywhere if you signed up. Okay. So now here we are having the different types of controller boards, right? So among these, so now we are going to use this ESP32 board, right? So after selecting that, so it will ask you and it will gives you some prototype IoT projects with the ESP32 microcontroller. And presently we don't need this, and just scroll down. So here you will find a different starter templates, right? So here we need to choose the first one, that is a simple ESP32. So just select that one. So if you selected on that particular ESP32, so here the ESP32 controller board is over here. So if you want to study about some basic documents, so you can click on the documents option here. So it will redirect you to the some documentation website. So here you will find some basic programs along with the hardware connections. Okay. So first I'm going to check a basic LED blinking program on ESP32. So here we are already having an example on this documentation folder. So just select this blink an LED on ESP32. So just give a click on it. Okay. So this is an example program which is already stored in this Workbee platform. Okay. So this is a basic Arduino program to turn on and to turn off the basic LED. Okay. So here first, so we defined the LED. So first, before going to make the connection, so first we need to decide, so for which pin we are going to connect the LED. So here I am taking the pin number 2 for the LED. So that's why here I am just defining LED 2. Okay. That means here I am going to assigning the, or I am going to connecting the LED to the pin number 2 in the ESP32 board. Okay. So this is pin number 2, that is D2. So next, as usual, so in the Arduino programming, we have the two main functions. So the first one is setup and the second one is loop, right? So the setup function runs only once at the beginning when the ESP32 is powered on. So it is used to initialize the settings such as the pin modes or any, if you are going to start any serial communication, all those initialization we need to put in the setup function, right? So here we define like pin mode LED comma output. So we can also write it like pin mode. So we can also write it like, write this command like, so 2 comma outputs. So both are correct. And finally, we need to use the semicolon at the end of the statement. So this is compulsory. So here we can write LED or we can write 2. Why? Because at the top we defined LED 2. So both are represents the same variable. Okay. So for that I am just putting one statement in the comments. Okay. So if we give the double slash means, so that statement will not run. Okay. So after that, so this statements, so this line configure is, so GPIO pin number 2. So this is general GPIO pin number 2 and which is set up as the output. Okay. So by writing this command, so we are going to tell the microcontroller that we want to send an electrical signal. It may be high or low to the second pin. Okay. So in this case, we will be using the pin to control an LED. So here LED is an output device, right? So that's why we defined LED comma output here. Okay. So output means, so here we need to write the signals, right? So if we come to the void loop, so the void loop function runs repeatedly as long as the ESP32 is powered on. So it contains the main logic of the program and it continuously executes. So whatever code is inside the function. Okay. So inside this loop, so first we have written the command like, so digital write LED comma high. So this line sets the GPIO pin number 2 to the high state. That means, so it will sense a voltage signal. So generally we can consider 3.3 volts or 5 volts in case of ESP32. So this line sets 2 comma high means, so which means it sends a high voltage to the LED. So when the pin is high, the current flows which turns the connected LED to turn on. Okay. So after that we have given like delay 500. So here the delay function passes the execution of the code for specified time. So here the argument is 500. So this 500 represents the 500 milliseconds or half second, right? So this means the LED stays on for half second. So before proceeding to the next command. Okay. So after that, after the delay function, so we have written like digital write LED comma low. So this line sets the GPIO pin number 2. So which is connected to LED to the low. So which means it stops the voltage signal. So we are giving to the LED pin. Okay. So when this pin is low, no current flows. So the LED is turned off. For how much time? So here also we have given the delay 500. So for half second, the LED will remains in the off state. Again, the loop will go to this first statement. Again, the LED will get on for half second and again it will get low for half second and again it will go on. So why? Because the statements which we have written in the loop will execute continuously for infinite times. Okay. So this is all about the program explanation. So what happened is in this loop means, so it will repeatedly execute it. So here the flow of work is like, so turn on the LED for half second. So wait for the half second and turn off the LED and wait for the another half second and repeat the process indefinitely and creating a blinking effect. Okay. So once if you have written the code, so just click on this run option here. So if you observe these circuit connections, so here the positive terminal of the LED is connected to the pin number 2 through a resistor. So here why we are using one resistor in between the pin number 2 and for the positive pin of the LED. So not in the circuit only. So in many circuits we will connect a resistor in series with an LED and the power supply. So why? So we are using a resistor in this circuit means to protect the LED from the excessive current. Okay, so we all know that LEDs are current driven devices, right? So that means, so they allows current to flow easily through them. So once a certain voltage threshold is reached, so without a resistor, if we connected the LED, so could draw too much of current, so causing it to overheat or burn out. Okay, otherwise it will get the permanently damaged. Okay, so to prevent that, so we are connecting a resistor in between the power supply and the positive terminal of the LED. Okay, so these LEDs have the low forward voltages, right? So once this voltage is reached, the LED will conduct and allows the current to flow freely. Okay, so here if you observe, in between the positive terminal and D2 means that is the GPIO pin, we have connected one resistor, and this is the ground or negative pin of LED, we connected it to the ground pin. Okay, so after checking the connection, so just click on the simulate option here. So the OP simulator will now runs your ESP32 code, and you should see the LED blinking on the virtual ESP32 board, right? So if there are any issues or bugs in your code, so you can make adjustments in the real time and you can return to simulation again. Okay. So it will provide you a simple debug and test your code. So you can pause and resume the simulation here. So if you want to stop the simulation, so just click here. So the simulation will stop. Okay. And here you can easily modify your connections. You can add or remove components as needed. Okay. So this makes Smokely as an excellent tool for learning and prototyping without need of any physical hardware. Okay. So after simulating it, so if you want to save your project, so you can just click on the save button at the top left corner. You are having the save button, right? So by just clicking this, you can save your project as a copy also. Okay. So running the after running your project successfully, so you can share this project by using the share option here. So by clicking on the share button and copying the project link, so this is you can share with your friends. Okay, so this is the great for collaboration or submitting your project to the instructors. Okay, so you can design your circuit over here and you can share the outputs to your guides. Okay, with your guides also. Okay, so this is all about how to design a circuit and how to write the code and how to simulate it in the Workfree platform. So now we will see another example. So now here I am going to delete the commands which we have defined previously. So okay, if you want in place of LED, we can place buzzer. Okay. So now we will write a code for a buzzer to control the buzzer. So how I need the code means for 2 seconds the buzzer is to be in the on state. So after 2 seconds it has to be off. After getting off, so in that state it has to hold for 2 seconds. Again it has to return to the on state. Okay. For that buzzer, so take the GPIO pin number 4. So to do that, so in the setup first we need to define the which GPIO pin we are going to use. So here I am using the GPIO pin number 4, and here the buzzer also an output device, right? So it is not giving us any data. So here we are just controlling the output device. So that is buzzer. So after defining the pin mode, at the ending of the line, we need to put the semicolon. So in the setup, So I initialize the GPIO pin which I am going to use. So in the loop we need to put the main logic. So here, okay, tell me, so how many states the buzzer is having? So is this a digital one or an analog one? So here which function we need to use? Digital write or analog write? So here we need to use the digital write because the buzzer is having only two states. Yes, either high or either low, either on or off. Okay. So digital, here W is capital. So digital write. So 4 comma high. So for how many seconds we need to hold the buzzer in high state? So here I am giving the delay of 2000 means 2 seconds. So for 2 seconds of time, so it will be in high state. So after that I am just writing, so digital write. So 4 comma low. After that we need to put the semicolon. Here I am again giving delay for 1 second. Okay. So this is my main logic. So the code in the loop repeatedly execute. So here the workflow is, so first we will turn on the buzzer and we will wait for 2 seconds, and after that we will turn off the buzzer for, and we will wait for the 1 second. Okay, so repeat the process indefinitely. And okay, so after writing the code, now we need to do the modifications in the circuit, right? So just click on this LED and here you will get the delete option. So just delete the previous components and the connections. So you can use the arrows in your keyboard to move the ESP32 board on the screen. You can use up and down and left and right arrows. Okay. So now we need to connect the buzzer to this ESP32. So for that you need to click this plus symbol here and you can select the buzzer. Or simply you can search for the buzzer. And you can place it wherever you want. So after placing it, so now we need to make the connection. So here the red color indicates the positive terminal of the buzzer and the black color indicates the negative terminal of the buzzer. So in general, so we will connect the negative terminal to the ground, right? So just click on this point. So and you will get a wire to connect it to the ground. So here you will find the ground. So just after reaching the point, just give a click over here. So the connection is made. And after that, we need to connect the positive. So where we need to connect this positive wire, I mean positive terminal of buzzer, for which pin we need to connect? Yes, very good. 4. For 4, we need to connect the positive terminal of the buzzer. So where is the pin number? For here, we will find the D4, nothing but the fourth pin, fourth GPIO pin. So just give a click on it. So the connection is over, right? So after making the connections, so what we have to do now? So we need to just click on the simulation option. So here, okay, sorry, it's my mistake. So here I just written the low in lowercase, but here we need to mention the low as uppercase. So again, just simulate this one. Yes. So if you observe, So in place of buzzer, we can connect LED also. So just delete the buzzer and you can select the LED. So just drag it to wherever you want and just place it. So if you want to connect LED means we need to place a resistor, right? So select a resistor, just give a click. So if you want to rotate this one, so you can just click on it. Okay, and you can rotate. Okay. So and from here you can drag it over here. So from positive terminal of LED to resistor, and from another end of resistor to pin number 4. Okay. So now we need to connect the negative pin of the LED. So we will always connect the negative pin to the ground of the microcontroller. So here you will find the ground. So after placing the connections, so just click on the simulation. So here you can observe. So the LED is getting high for 2 seconds and low for 1 second. Okay. So with this, the session is completed. Thank you everyone.